This is a Columbia 75 video that illustrates a scenario involving two patients with hyponatremia. We strongly suggest that you watch the core concept video first. Dr. Brian Block will take it from here. Here's Brian.
Okay, pretend we have two patients, patient A and patient B. Patient A has a measured sodium of 125, while patient B has a measured sodium of 131. So who are we more worried about? Patient A obviously has a low measured sodium level, but we need to determine if this is actually reflective of low tonicity. How do we do this? Clearly we need more information than just the sodium, so let's look at the glucose. Hyperglycemia, you will recall, causes a translocational hyponatremia because glucose is an effective osmole that draws water out of cells. If this patient with a sodium of 125 turns out to have a glucose of 750, well, then their corrected sodium is normal. We see this by calculating their corrected sodium using the equation I just described, which is measured glucose minus normal glucose, in this case 750 minus 100, which equals 650, divided by 100, which is equal to 6.5, and we then multiply that by the correction factor of 2.4 to get 15.6. Adding this to the measured sodium of 125 gives us 140, which is normal. Further, if we add in measurement of the BUN, say 10, then we can calculate the osm to be 2 times 125 plus 750 divided by 18 plus 10 divided by 2.8 equals 295. The osmolality is elevated, making this a case of hypertonic hyponatremia. Now let's look at patient B. Initially, this patient seemed to have less worrisome hyponatremia because the sodium level was 131, which is not as low as patient A's 125. However, we have to look at this glucose in the context of the rest of patient B's Chem7. Well, if the glucose is normal in this person, 100, then the corrected sodium is the same as the measured sodium, 131. The low sodium is not made up for by other effective osmoles, meaning the tonicity is low. This is the situation in which cells will swell, and therefore we are more concerned about patient B's hyponatremia. To make one more thing clear, with patient B, let's assume that they are in renal failure, with a sodium of 131, a glucose of 100, and a BUN of 92. What is the osmolality? Using the same equation with which you should now be familiar, it turns out that patient B has the same osmolality as patient A, 295. So why is it that patient B's hyponatremia is more concerning? Recall, BUN is not an effective osmole. It can cross into cells. Therefore, it cannot cause a translocational hyponatremia. So while the osmolality is high in both patient A and patient B actually has a low tonicity because much of the osmolality is made up for by an ineffective osmole, BUN.